Welcome to a new session of analog circuits. In today's class 1 under PN junction diode, we are going to see the application of diode in the form of clipper circuit. So already we have seen from our past classes what is forward bias. Means diode gets conducted under positive cycle, and reverse bias, the diode is reverse biased, and again the reverse input is given as input to this diode, and again it starts conducting. So anyhow, when we use this kind of forward bias and reverse bias conditions for practical application, that is, first we go with the negative series clipper circuit. For this, you can see here diode is shown in this direction, and input is given as supply, and output is obtained across resistor when current starts flowing. Okay, so what is the input is a sinusoidal wave. Okay, you can see the intervals how it is designed. It has a zero value at initial stage, then it reaches to the peak value, then come back to the rest position. We can imagine this position to be at 180 degrees, then it reaches to the negative peak, and again the cycle gets repeated. So if this kind of input is given to a diode in this direction, what happens? The diode acts like a switch. When the diode starts acting like a switch, it gets on under forward bias. Means what? Under positive supply, the diode gets on. And when current starts flowing, the diode current, it will be flowing through the resistor R, and output is obtained across the resistor. That output voltage is given by the current multiplied with the resistor. So ID is the diode current which is flowing into this circuit. The entire current is nothing but is the diode current itself. And under reverse bias, the diode, it doesn't conduct because it is a unidirectional device, so it acts like a open circuit, and hence we don't receive any output voltage across resistor. Pertaining to this, the voltage is zero across resistor, and hence we are going to get the output voltage signal in this form, which is, you can see, it is on for positive half, and for the negative half it is cut off, and again for the positive half it is on. So since the negative half is cut over here, that's why it is acting like a negative series clipper circuit. What happens if we go with the positive series clipper circuit? So for the positive series clipper circuit, you can see the diode conditions are reversed. When diode is reversed, for input voltage, that is for the positive half, the diode acts like a open circuit, and there is no voltage across the output. And for the negative half cycle, the diode gets on, and the direction of the current, you can see it is flowing in anti-clockwise direction. Means what? The negative half is given as an input to the diode which is in reverse bias. So that is how we receive the voltage across the resistor. So for this input signal, this is the output signal, and you can see the positives are off and the negatives are on. Since the positive is off, it is named as positive series clipper circuit. What happens when we go with the negative parallel clipper circuit? For negative parallel clipper circuit, you can see the diode position is in this fashion, and the output is across diode only. Okay, so what happens when the input supply is forward bias? Means the positive supply is given. So for the positive supply, the diode receives the uh, positive signal, and diode is in its opposite direction, so it will be open circuit, hence there is no output across the diode. And when negative cycle is given as input to this diode from the negative side, the diode gets on, and this is how the direction of the current is shown in anti-clockwise direction. So for this, the output voltage will be what? You can see the output is positive, it is on, and for the negative it is off. Again for the positive it is on, and since the negative is off, it's a negative parallel clipper circuit. And what happens if we go with the positive parallel clipper circuit? For that, the diode gets on during positive half, and it gets off during negative half, and the output is obtained to be in this fashion. You can see the positive is off, and for the negative the condition is getting on, and this kind of representation is known as positive parallel clipper circuit. Now what happens when you combine this all analysis together, that is for negative series clipper circuit, For input sinusoidal signal, this is the output signal. For the positive series clipper circuit, for input sinusoidal input, this is the output. Similarly, for negative parallel clipper circuit, the input is this and the output is this. Finally, for the positive parallel clipper circuit, the input is sinusoidal and the output is obtained, which is in this fashion. Okay, we can have a demonstration in a MATLAB. I'm showing you only for the negative series clipper circuit. You can see I have a diode over here. The input voltage is 100 volts at 50 hertz, and it is given as an input voltage, and the output is across 20 ohms, and that is treated as output voltage. So you can see here from and go to ports are taken outside, and that is given to a scope, and the time duration I have taken as 0.04 seconds, and I'm going to run the circuit, and you can see here the output and input for this clipper circuit. So how it is on, and from 0.01 to 0.02 it is off, and the waves gets repeated. So this is how you can do a MATLAB simulation for different models, for different designing circuits. I have already shown here. So I can show you other circuits like this. You can see here the diode is reverse bias for series condition, and for the parallel condition the output is taken across the diode, and this is the negative parallel circuit. And finally, for the positive parallel circuit, this is the circuit here. Again, when you run this, you can check the output. Yes, you can see here the output is obtained to be in this fashion for given input sinusoidal. So I hope you like this class, and please share among your friends, subscribe to this channel, and press the bell icon for the future notifications. Thank you.